Welcome, scholars. Lesson 9.3, Calculating Beta and an Introduction to Power. Okay, let's look at a real-life example involving paramedics. Victims, life-threatening injuries, you want to get to them within 8 minutes. Now, looking at one particular city, the mean response time was 6.7 minutes with a standard deviation of 2 minutes. By the notation, I can tell that those numbers came from the population, so those are parameters. Okay, even want to do better going forward. So the city provides training to improve these response times. At the end of the training, they're going to start taking samples of the calls to see if they actually get a lower response time. They will use a significance level of 5%. A lot of this first part is going to be practice. So what I'm going to do is pose a question. You should pause your video, try to answer it, then play and see if you got it right. So the first instance of that is determine the null and alternative hypotheses. All right, let's see if you got them right. The null would be no change from the previous year. 6.7, always an equal sign with the null. Alternative, we want to improve, which in terms of response times means less, so the alternative is less than 6.7. Significance level 5%, so 0.05. Next challenge for you. From the videos that you saw from Miss Zara, you learned about type 1 and type 2 errors. What would those be in the context of this problem? To help you out, here's the chart she provided last video. Okay, let's see how you did on those. Type 1 error, that's where you rejected the null, but you shouldn't have. So, in the real context, rejecting the null would mean that you conclude the alternative. So you would have thought the response times did improve when in fact they didn't. Next question, what is the consequence of this error in the context of the problem? Pause, come back. Consequence, you're going to implement the program, but it really doesn't help. So why is that bad? Well, you wasted time, money, resources to actually implement the program. Now, how often will this happen? In order to reject the null, we want a sample that is unusual to happen by chance. We set a significance level of 5%. So how often are you going to actually make that mistake? Exactly that number, 5%. So type 1 error, significance level equal. Okay, type 2 error, let's see if you got that one right. It's where you failed to reject the null, but you should have rejected the null. All right, so in context, you're concluding there was no change in response time when, in fact, the response times had improved, but you didn't catch it. Now, a little detail here. You don't want to accept the null and say, yes, it is 6.7. You fail to conclude that it is less than 6.7. All right. Consequences of making this error. You don't implement a program that was actually helping reduce the times. And in effect, this one could actually cost people lives because you're not implementing the plan that may have worked. Okay, how often does this happen? This happens beta. So we had alpha for the type 1, type 2 is beta, but now how do you calculate beta? How often does a type 2 error occur? Okay, so how do you calculate beta? I added something to the problem here. So they did the training, they want to see if the response times are improving. So the next year they took a sample of 400 of the response calls and they took the average of that. That average would be placed somewhere on this sampling distribution of means. Real quickly, think about what do the labels look like on the bottom of that sampling distribution. You learned that last chapter. Pause, come back. Okay, there's a hint for you. The mean of the sampling distribution equals the original population mean. The standard deviation of the sampling distribution equals the original standard deviation divided by the square root of the sample size. Plug it in the numbers. you will get 6.7. We got that from the hypothesized mean, meaning the one we assume to be true. The standard deviation, 2 divided by 20.1. Okay, I've added a bunch of information to this slide. I put the mean of the sampling distribution. I counted out 2 standard deviations each way from that mean. I put the 5% significance level in here, and I have a critical value. This is going to be the bar that determines if my sample ends up on one side of it, I'm going to reject. If it ends up on the other side, I'm going to fail to reject. I knew the bar went about there. Rule of thumb, 2.5% would have been at that second standard deviation over in the tail. So I know it's about here. Use your calculator, find where that value is exactly. Put these 2 places up here, fail to reject, and reject on the sides of that critical value bar. Okay, let's see if you got it right. Here, I actually have a percent, and I want to find the position. Inverse normal. 5%, mean of 6.7, standard deviation of this sampling distribution, 6.53. It's about where I had anticipated it to be. Okay, if I get an unusual sample, I'm going to reject. That will be this side. If I don't get an unusual sample, I'm going to fail to reject. That will be if my sample mean ends up being on that side. Remember, I'll take the 400 calls, find the average, and then see where that average lies on this sampling distribution graph. So how do we calculate beta? Well, recap. Beta is a type 2 error. You failed to reject when you should have. So what does that mean about the mean being 6.7? It really is not. I have to add to the story now. So last year, after the training, we took a census of all the response time and found that the true mean was not 6.7, it was actually 6.4. So we failed to reject that it was 6.7, but we should have. So how often will that happen? Well, here's the graph again. Pause for a second, see if you can put the pieces of this complex puzzle together. Okay, let's calculate beta. The blue graph, blue distribution, sample size 400. Remember, it's the mean of those 400 is somewhere on this graph. Here's the critical value. It came from the null hypothesis. Reject is on this side. Fail to reject on this side. Only problem, this blue distribution does not exist. The true mean is 6.4. So really, the distribution is this red graph. This blue one doesn't exist. So the sample we took actually came from this sampling distribution. Same standard deviation because our sample size was still 400, so same spread. Now the question is, how often from the real data would we have gotten a sample where we failed to reject? Pause for a second, see if you can figure out what is the area of this region right down here. Okay, I have a normal distribution centered at 6.4. This boundary is at 6.5355. I want to find an area given a position. So I am going to do a normal CDF calculation on my calculator. From here to infinity, 6.4 for the mean, standard deviation. So how often do we actually make a type 2 error? Little less than 9% of the time. Okay, I have to make a confession here, folks. AP exam, rarely have they asked you to calculate beta. In fact, it only happened one time on a super frappy problem, which is the extension problem. And based on this year being a distance learning, they're probably not going to have you calculate beta. But like to show you the foundation of it. It gave us a lot of good practice in making calculations, so still feel it's worthwhile. But what I really want to get to is we have this critical value, type 2 error. What in the world does the other side of this graph represent? Think about it for a second. Come back as I finish coloring this in. Okay, what does that represent? Well, that represents the percent of the time that you actually rejected the null, and guess what? You should have. That is really powerful. You actually found the conclusion that you were hoping to find. And you'll notice right there, I actually said the word of what the mathematicians have named that area. That area is called power. And power and type 2 error complement each other. They add up to 100%. So power, let's define it quickly. It's the ability of a test to reject the null when it should have. Notice I went back to the table Miss Zara showed you yesterday and put some of the symbolic things on there now. Okay, that's the end of this video. The next one's going to talk about a little bit about the interpretations of power and how do you get power.